Hello, so in this video we're going to be looking more into forces, and now in this video we're going to look at forces as vectors. Okay, so firstly, as a recap, if you haven't already, we've seen it, you might have seen it in pure maths already, but we've also seen vectors in the first chapter in mechanics, there's two things you need to know for this particular video, as a recap, as a reminder. Well, firstly, we can use I and J notation. So what I mean by this, well, firstly, if we just have a column vector, so that let's say we have 3, 5, right? From GCSE, right, you'd be familiar with, well, if we plot this vector on, say, an XY grid, right? Well, 3 across, so it'd be 3 here, and 5 up, so it'd be up here. So that's my point. Then the vector joins from the centre to the origin to the point, okay? We can write this in what we call I and J notation as 3 lots of I, add 5 lots of J, okay? So the I part is essentially the x-axis, or the x part, and the J is sort of the y-axis. So I would be here and J would be there, okay? Another example, we could have perhaps minus 2 minus 3. So then we would have minus 2 here, minus 3 down here, which leads me to this point here. And so we'd have that vector there, okay? The other thing we need to know, as well as I and J, is to work out the magnitude or the length of a vector, okay? Now, in general, if we have a vector AI and BJ, so coefficients A and B, then the magnitude or the length is given by the root of the coefficients squared, like the Pythagoras theorem, right? So in this example, if it was to calculate the magnitude of the vector 3, 5, so the vector 3i and 5j, we would write 3i add 5j with these two lines. This represents the magnitude. These two vertical lines at the end are the magnitude, and so it'd be the root of, well, 3 squared add 5 squared, and that would get me root 34, okay? That tells me the length of this vector, so the vector 3, 5, so 3i and 5j here, this whole line has a length of root 34. That just comes from Pythagoras, right? If I then say that's 5 up and 3 across, hopefully you can see then that the hypotenuse here is the root 34. Anyway, if we were to calculate the length of this vector, so if we had the root, if we said minus 2i minus 3j here, so this vector is minus 2i minus 3j. Then the length of that vector, that's going to be root of minus 2 all squared add minus 3 all squared. Okay, because the two components, I square each of them. And so if I do that, I get root 13. Okay. And so that the length of this vector here, which is that vector, is root 13. Okay, so that's what we mean by magnitude. Okay, so to calculate the length or the magnitude of a vector, so you need to be able to recognise what I and J mean, which basically means the x and the y part, and to work out the length in this way. Okay, but hopefully that was a recap. Okay, so we're going to look at applying. What we'd looked at forces last time into vectors. Now, we looked at last time, there was a vertical and horizontal component, right? So let's say we have this little ball here. It has a force of, let's say, 20 newtons up and 30 newtons to the right. Well, there's a vertical, so an upwards force, and a horizontal, so a right force, a left to right force, which act in two different directions, right? So, well, what do we know? What thing do we know has, well, a horizontal and a vertical component? A vector, right? So actually we can translate this into a vector to say that this is the force as a vector well, horizontally. So remember, if it's xy, well, the x is sort of the horizontal part of 30 and the y part of 20. Okay, so we can say the force here as a vector is 2030 newtons. Okay, so we can express forces vertically and horizontally as a vector. Okay, right, so let's have a look at some examples. So here we're told the force is 2i and 3j, 4i minus j and minus 3i add 2j, and this other vector ai and bj act on an object when it's in equilibrium. Find the values of a and b. Now equilibrium, that is another word for balance. Okay, so what that means is the resultant force has to be set to 0, right? We saw that last time. There's no overall force because all the forces are balanced. Okay, now we don't need to when we got vectors, the good thing is we don't really need to plot the vectors. What we can do here is you just simply add all the vectors and make it equal to 0, because that would be the overall force of 0. So if I add all these vectors, 2i and 3j, add 4i minus j, then the next vector I add minus 3i plus 2j, and then add this ai and bj, and then have to set it to 0. Okay. What I can do here is, to make my life easier, well, we need to add the i's and j's, right? Just think about it collecting like terms. But what I can do to make my life easier is just convert all of this into as a column vector. So this vector 2i and 3j is 2, 3. And then 4i minus j is 4 minus 1. And then we have minus 3i, so minus 3 and plus 2. And then this a and b. And we have to set it to 0. And at this point, we're just adding column vectors, which you should know how to do. So if we add all these vectors, well, we just add the top numbers first. So 2 and 4, then minus 3 add a. Well, that's going to be 3 add a. And then for the bottom numbers, we have 3 minus 1 plus 2 plus b. That'd be 4 plus b. And then we set it to 0. Now, as a vector, 0 is just 0, 0. Okay? So then at that point, hopefully you can spot we got some equations we can get from this, right? We can equate the top and the bottom parts. So we can say 3 add a equals 0 and 4 add b equals 0. Then it's just solving a simple equation. So then I can say that a is negative 3 and b is negative 4. And those are my solutions there. Okay? So that's the idea. Okay? So when we're given vector forces, so forces as vectors, we can add all the vectors to get the overall force. And then if it's balanced, we set that force to 0. Okay? Right. Okay. Let's have a look at this question here. So here we're told a particle begins. Oh, okay. It says this a little bit first. It says in this question, I uses the unit vector due east, and j represents the unit vector due north. Sometimes I do say that. What that essentially means is, well, north. You have north, east, south, west, right? Never eat shredded wheat, but that's your compass directions. You do need to know these, but the north is sort of the positive y-axis, right? East is the positive x-axis. So what I'm saying is, what this is saying is, if I is east, then that's east, so I is there, and j is north. So hopefully it's basically the x and y-axis, essentially, so nothing really telling there. Anyway, just anyone's confused by that. That's essentially what that part means. Okay, then we're told a particle begins at rest at the origin. It is acted on by 3 forces with these 3 vectors. Find the resultant force in the form pi and qj. So we need to give it an I and j. Now, so the resultant force, again, we're going to be adding all the vectors together. So firstly, we have the vector 2i and 1j, so it's going to be 2, 1. Add 3i minus 2j, so that's going to be 3 minus 2. And then we have minus I plus 4j, so it's going to be minus 1, add 4. Okay, and so the resultant vector is if we add all these together. So add the top numbers, 2 and 3 and minus 1, that is going to be 4. And then bottom, 1 minus 2 plus 4, that's going to be 3. Okay, so that's my resultant vector, my resultant force. Okay. Okay, but then I need to give it I and j in I and j form here, so it needs to be in terms of I and j. Well, as we just discussed, we can convert a column vector. Well, this is going to be the I part and the j part, right? The x and y. So it's going to be 4i add 3j. And there we are. Then in part B, it says to work out the magnitude and the bearing of the resultant force. So bearing is all to do with angles. Think back to GCSE. So what we're going to do is just plot this. I think it's going to be a lot easier to see what to do if we plot this vector. So, again, I've taken a sort of XY grid, right? Or I and J, if you will. Well, 4i, that's going to be 4 across here. And then 3i is going to be 3 here. Again, just literally treat it like an X and Y coordinate. Then we have our point here. So the vector is the line from the origin to there. Okay. And so there we are. Now, it wants firstly the magnitude. Well, as we also just discussed, the magnitude is the length. So the magnitude, that's going to be the root of the 2 parts all squared. So you've got your 4 squared and your 3 squared. So the I and the j coefficients, they're all squared like Pythagoras theorem. If we work that out, but that'll just get me 5. So the length of this vector here is 5. Okay. And so there we are. Then it says to work out the bearing. Right. Now, the bearing, if I just draw this vector here, so it has a length of 5. Now, horizontally, the length is 4, right? So it's going to be 4 across, and then it's going to be 3 up, right? So we have this triangle here. Hopefully you can see that. So I've just literally I've just taken this diagram, what I've drawn as a triangle here. Hopefully you can see where the lengths match up. Okay. So at that point it wants the bearing. So the bearing, if we start from here, remember, think back to GCSE, bearings start from a north line. They're a special type of angle where we measure it from the north line. Okay, so actually the bearing is going to be from the north line, so on top, facing forward, all the way to the actual length, the line itself, so the vector. That is my bearing theta. But what I have here is a sort of triangle, right? So if I call that then, if I call that angle x, right? Well, actually, hopefully you can spot we've got a right angle triangle here, so I can work out x, then I can work out theta, okay? If I was to use this triangle to work out the angle x, well, again, we've got a right angle triangle, we can use SOHCAHTOA. Well, you can pick your poison, right? You pick any way you want to work out x. Well, x is opposite the 3, so that's the opposite side. 4 here is adjacent, and the 5 is the hypotenuse. So you can use whatever SOHCAHTOA you want. So sine, cos and tan. Let's pick tan. Okay, so tan x is the opposite over adjacent, which is 3 over 4. So therefore, to x is going to be the inverse tan of that. And so that will get me 36.869 blah 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 degrees. Okay, that's x. Now to work out theta, the bearing, well actually the whole bear, hopefully you can spot theta and x. So from the north line it's just one right angle of 90 degrees, right? So that means theta and x has to equal 90. So therefore theta is going to be 90 take away x, which would be 90 take away this 36.869. And then if we work that out, we get 53.13 degrees to 2 decimal places. And so the bearing then, so again, pay attention, we want the bearing. The other thing to pay attention to, if you think back to GCSE, is that bearings, as well as starting from a north line, there's always 3 digits before the decimal point. So we have 53, that's 2 digits, so we need to say 053. Okay, degrees. Okay, I'm going to say two significant figures. So there we are. So that, okay, pay attention to that, right? So that's the bearing. Okay. Okay, and then we have part C, which says describe the motion of the particle. Okay, so again, say we have this particle, right? This object. Now, the resultant force that we worked out to be 4i and 3j, or 4, 3 as a column vector, right? That's the resultant force. The overall force that acts on this object, which I just, which is this box I've drawn, right? So, if the resultant force is 4, 3, as we just saw, this is the resultant force, right? So, it's going to be this line acting on the box like this. Okay, so it's going to be 3 across, 4 across and 3 up, and so that is the resultant force. Okay, it acts at an angle. Okay, and you can imagine it could be like tugged by a piece of rope, something like that, right? That's the overall force acting on this object, right? That pulls it in this direction. So what will happen is the particle will accelerate. In the direction of the resultant force. Okay. As essentially you can imagine it as this force here is being where it's being pulled to. Okay, it's being pulled forward at this sort of angle, so that's the force. Okay, so that's the idea. Okay, so it will accelerate, so it will keep speeding up and up and up in that particular direction. Okay, so there we are. Okay, let's have a look at some more questions. So now we're told here the force is 2a and 2b minus 5b and 3a and minus 11i minus 7j act on an object in equilibrium. Again, that means it's balanced. All the forces are balanced. Now, with that in mind, our forces then, again, we have the vector 2a and 2b. Then we have minus 5b and 3a. And we also have minus 11 and minus 7. If it's an equilibrium, it has to equal 0. Okay? Because the resultant, if we add all the forces up, which is the resultant, it has to be 0 because it's in equilibrium. It's in a balanced state. Okay? So, if we just do this then, if we add all the vectors up, well, if we add the top numbers, we're going to get 2a minus 5b minus 11. And then 2b add 3a minus 7 equals 0. Now 0 as a vector is just 0, 0, right? So all the top and bottom numbers have to equal 0. Right, so at that point we just get the equations. 2a minus 5b minus 11 equals 0. And 2b plus 3a minus 7 equals 0. So we get these simultaneous equations, right? So 2a minus 5b equals 11. And 3a plus 2b equals 7. Okay, so at that point we just solve these simultaneous equations. You can do that however you want. So I'm gonna probably use elimination. So I'm gonna want to make the a's match. Well, I notice 2 and 3 6 goes they both go into 6. So if I scale the two equations, so if I multiply this by 3, so if I multiply the first equation by 3, I'm going to get 6a minus 15b equals 33. And then if I double the second equation, I'm going to get 6a add 4b equals 14. And then how can I get rid of the a's? I can subtract the equations. So if I do that then, well, 6a minus 6a goes away. minus 15b minus 4b goes to minus 19b equals 33 minus 14, which is 19. Well, there we are. So therefore minus 19b equals 19, so b equals negative 1. Okay. Then to find a, I can substitute that back into either equation. I'm going to substitute it into the first one. So 2a minus 5b, so that's going to be minus 5 lots of minus 1 equals 11. So 2a plus 5 equals 11. Therefore 2a equals 6. So therefore a equals 3. If I squeeze it in there. So there we are. Those are my values. Okay. Okay, so we've got this question here, and now we're told that three forces F1, F2 and F3 act on a particle, and we're given the vectors for each of these three forces, and it says given that the particle is in equilibrium, again that keyword means balanced forces, we need to find P and Q here. So again, we've got these three forces, F1, F2, F3. If we add them up to get the overall, the resultant vector, right? The resultant force, we get, F1 is here, minus 3 plus 7. F2 is I minus j, so that's going to be 1 minus 1. And then F3 is pi, qj, p and q. Okay, then it's an equilibrium, so all of that has to be 0 overall. If we then add these three columns, we get minus 3 and 1 and p, so that's going to be minus 2 and p. And then 7 minus 1 is 6, add q, equals 0, 0. Okay? Therefore, we get that minus 2 add p is 0, and 6 add q equals 0. Where we can solve each of these equations to get that p has to equal 2, and q has to be minus 6. So those are my values of p and q for part A there. Then we're told the resultant of the forces F1 and F2, so only the first two forces, not all three of them, the resultant of those two is this R vector. So R is going to be F1 and F2, which is, well, F1, again, F1 is minus 3i to 7j, so minus 3 and 7, and F2 was I minus j, so it's going to be 1 minus 1. If we add those up, we're going to get minus 2 and then 6. So that's the resultant of those two vectors. It wants to find the magnitude. Okay. So then, as we discussed at the start, if we said that the magnitude, which is what we say R with these two vertical lines, is the root of the two components squared, the two numbers. So minus 2 all squared adds 6 squared, right? And then if we put that in the calculator, we get 2 root 10. And there we are. That's the magnitude of the vector, right? Then it says, calculate to the nearest degree the angle between the line of action of R and the vector J. Okay, that seems a bit like what the hell is going on there, right? What I'm going to say first is just plot, because it's to do with angles, it's going to be helpful to just draw the vector R. So R, again, if I remind you, is minus 2, 6, or minus 2i and 6j. So if I plot that on, again on some sort of XY grid or I and J grid, minus 2i plus 6j. So this vector here, which is R, minus 2 on sort of the x-axis, right, and 6 on the y. So we get this point here. So that's my vector from the origin, okay? So that's the vector R, right? Now, what it wants is the angle between the line of action of R. Well, that's the line of action essentially, right? Just the line, right to the point. So the vector R and the vector J. Now again, as I remind you, I is basically the x-axis and J is basically the x-axis and J is basically the y-axis. So what's essentially what this is saying, if I make it a bit more simplified, the angle between the vector and the y-axis, okay? So if it ever asks for an angle between a vector and between j, if it asks for the angle between vector j, it means the angle from the y-axis, okay? Well, if we go from the y-axis, so this axis here, to the vector, well, it's this angle here. That's the angle we want to find, okay? And so if I draw that sort of triangle we got then, right? So this is theta. We know that, as we just discussed, the magnitude is 2 root 10. So the hypotenuse is 2 root 10. Then this side, this vertical side, right? Well, that's 6, right? That corresponds to 6. Because that's how far we've gone up in. We've gone up by 6. And we go across by 2, okay? So we end up with this sort of triangle. Again, this right angle triangle. So hopefully you can see how I got that right. So there we are. So then to find theta in this right angle triangle, we can use Sokotoa. I'm going to use tan. So tan theta, well, the opposite, well, it's facing the side 2. So it's going to be 2 over 6, which is a third. Well, tan, if you do inverse tan of that, of 2, 6, that would be 18.4349 blah 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 degrees. So therefore theta is this angle. So theta is 18.43 degrees to 2 decimal places, okay? So that is the angle between the vector, so the line, and the y-axis there, okay? Okay, so yeah, that question just is worded really horribly, but once you sort of decode it, how I've done here, hopefully it makes a lot more sense about what angle you're trying to work out there, okay? And hopefully you understand how I got this triangle as well, okay? So again, if I draw, if this is the vector, right? So we've gone 6 up, and then 2 across, okay, to get this triangle here, and the length is the magnitude of 2 root 10 there, okay, hence I get that triangle, okay. There we are. Okay, so we've got this question now. So now we're told a particle is acted upon by 2 forces, F1 and F2. F1 is 3i minus 2j, and F2 is ai and 2aj. Now, part A doesn't actually ask to find the resultant, it asks to find the angle between F2 and I. Again, very weird question, but again, if I draw F2, so F2 is AI and AI and 2aj, or as a column, A and 2a. Now, if I was to plot that on, again, on some sort of XY grid, the vector will look like this. So A would be, say, here, and 2A would probably be all the way up here. Okay, so 2 lots of that. If I then draw my vector, there we are, okay, from the origin. Again, it is definitely on the positive axis because A is positive, okay. I'm told that, so it would look like this. Anyway, so to decode it, the angle it wants between the vector F2 and I, again, I is basically the x-axis and j is the y-axis. If it wants it between I, it wants the angle from the x-axis, okay? So from the x-axis to my line, it's going to be this angle here, right? Between the axis, the x-axis or the y-axis and the vector. So there we are. So again, we get this triangle. So we're going to go A across and 2A up. So we get this triangle. That's theta. This is A and that's 2A. I don't know my hypotenuse, really. I don't need it though, because I can use tan theta. So tan theta, again, opposite is 2A over A. Now we don't need to know what A is, because actually look, the A's cancel. So I'll just get tan theta is 2. Now I can find inverse tan. So theta is inverse tan of 2, which is 63.43 degrees. And there we are. So that is the angle there. Cool. Then we're told the resultant of the two vectors is r. Okay. Then we're told in part B, given that this resultant vector r is parallel to this other vector, find the value of a. Okay. So firstly, we're going to need to work out r. So again, r, the resultant, is adding these two vectors together. So okay, well f1 is 3i minus 2j, so it's going to be 3i minus 2j, so 3 minus 2, and f2, as we just saw, is a and 2a. If we add them together, we get 3 plus a, minus 2 plus 2a. Okay. Now, what we're told is the vector is this vector r is parallel to this other vector. Now, what you also need to know, even from GCSE, you should have seen this. If you have two vectors at, say, x and y, if these vectors are parallel, they are multiples of each other. Okay, so then one vector x is a multiple of y. So because this multiple k represents that they're multiples of each other. So k is a multiple. So what we're going to do here then, now we're told that this vector here, this r, is parallel to this vector 13i and 10j. So r is parallel to 13i, what was it? Add 10j. So what we can say here is, therefore r, which is the vector 3 at a, or a at 3, and then 2a minus 2, this is the vector r. And then we can say that because it's parallel to this vector, it's going to be a multiple, so k, this number k, a multiple of this vector of 13, 10. Okay, so that's because they're parallel, right? Now at that point, it's just again some algebra. So if I multiply this by k, that's going to be 13k and 10k. So therefore, that's a at 3, 2a minus 2. And so at that point, if I then compare, I get these two equations. So a at 3 equals 13k, and 2a minus 2 equals 10k. Or if I rearrange it to get a and k on one side, I get a minus 13k is minus 3, and 2a minus 10k is equal to 2. Okay, I get these two equations. They're simultaneous. Right, so what I can do here is, again, I can eliminate. So I spot if I double the first equation. So if I do the first one times 2, so then I'd get 2a minus 26k equals minus 6. Well, actually then, I can eliminate the, so if I then rewrite the second equation down here, what can I do to get rid of a? I can subtract them, can't I? So then 2a minus 2a is 0. Okay, and then minus 26k and minus 10, that's a double negative, we add it. So minus 26k add 10k is minus 16k equals, and then minus 6 minus 2 is minus 8. So therefore we get minus 16k is equal to minus 8. So k is minus 8 over minus 16, which is a half. Okay, so k is a half. So then to find a, I can substitute it into either equation here. I'm going to substitute it into the first one. So then I'm going to get a minus 13 lots of k. So 13 lots of a half equals minus 3. So a minus 13 over 2 equals minus 3. So that means a, if I do minus 3, add 13 over 2, I get 7 over 2. And that is my value for a there. Okay. Yes, my value of a. And there we are. Cool. Okay, we're going to finish off with an exam question. And it's not too dissimilar to what we just looked at with the parallel stuff. Okay. So we're told, I probably gave the question away here by mentioning that actually, but okay, we're told here a particle P of mass 4 kilograms is at rest at a point A on the smooth plane. At a time t0, the two forces F1 and F2 are applied to P. Given that P moves in the direction of this vector, 3I at J. We need to get to this equation here. Okay, what we're going to do now, we're told that these two forces are applied to P and that P moves in this direction. Now, P, if we first calculate the resultant force, that's never a bad idea. The resultant force. So the resultant is going to be the two vectors added together, so F1 and F2. So that's going to be, well, F1 is 4I minus J, so 4 minus 1. And then F2 is lambda and mu. Okay, so again, you might not seen those letters before. They're just Greek letters. Okay, we call them lambda. So lambda is pronounced lambda, like this. It's written like this, and mu is mu. You might see them from time to time if you haven't seen them before, but that they're just letters essentially. Okay, fancy letters, but anyway, they're just constants. They're just hidden numbers. So okay, if we add these vectors, we get 4 add lambda minus 1 add mu. Okay, now that's the resultant force. We're told that the particle P moves in the direction of this vector. Now, the resultant force is where it's going to move to, isn't it? If that's the overall force, that's where P is going to move in, right? That tells me where P is going to move, because that's the overall force which is pulling P in that direction. So, so P is moving in the resultant force in the direction of the resultant force, right? Right, so P is moving in the direction force, but hang on, we're also told it moves in this direction of this vector here. Well, that's telling me that this vector then has to be the same direction as this resultant. In other words, the two vectors have the same direction, they are parallel, right? Which means we could say that the resultant is parallel to this vector here. So the vector 3I plus j. So then think back to what we just said. Well, if these two vectors are parallel, then that means they're a multiple. So the vector 4 add lambda minus 1 add mu equals 3I and j. Well, multiple, so multiple of 3I and j. So 3, 1. And so if we multiply by k there, we're going to get, if we multiply by k, we get 3k and k. Okay, so 4 add lambda and minus 1 add mu equals this vector here. So the two vectors are equal, so again we can now equate them, the bottom and the top numbers. So we get 4 add lambda equals 3k, and minus 1 add mu equals k. And again, these two are simultaneous. Now it's quite awkward because we've got 3 unknowns, right? We've got 3 unknowns into equations. It's a bit weird, but we just need to show this equation here. Now, what do I notice? There's no k in here, only lambda and mu. That tells me I'm going to need to eliminate k from these equations. If I'm going to eliminate then, well, probably the easiest thing we could do perhaps is substitute k, right? So I already know here that k is minus 1 add mu. So if I sub then k is minus 1 add mu into the other equation, so into the first one, I'm going to get 4 add lambda equals 3 lots of k, so 3 lots of minus 1 add mu. If I expand that, I get 4 add lambda is minus 3 add 3 mu. And then if I just move everything to one side, so I'm going to get 4 add 3, that's 7 add lambda minus 3 mu equals 0. Does that match the equation? I need to rewrite it ever so slightly. So I'm going to have lambda minus 3 mu add 7 equals 0. And now that matches exactly the equation I get. So I'm done there. Okay, and there we are. That's the equation they wanted. Okay, so that's it for this section. So hopefully you get the main idea now, that essentially we can represent forces as vectors, and then we can find the resultant by adding all the individual vectors together. Okay, and there we are. So I'll see you next time.